Hey everybody, welcome to the next episode of the Stocks and Crypto Sequel show. I had some hardware issues, so I hope everything is working correctly now. So let me kick it off. Oh, I actually have uh, Ryan here with me. Let me pull you into the stream if I find those buttons. Hey Ryan.
Hello, hello. Let's make sure my stuff is set up correctly. There we go.
Which
There we go.
one? This is the one
There we
I'm looking
go.
for.
That's a good one. I like that one.
How are
How you
you?
doing this morning, Tilla? I guess it's afternoon for you. So
Yeah, it's afternoon and it's the middle of December. It's really cold. We got the first snow uh,
okay,
this week. Yeah, so
like
that's exciting.
appreciable snow.
Well, to be honest, not really. Uh,
Okay,
but as I remember, last year we didn't have snow until like January or something like that.
right.
So yeah.
That's awesome. Well, I have a pond and there has been ice on it a few mornings, but we're supposed to get 60-degree weather next week. So I don't know.
Wow.
Anyway,
Okay, so
what are we
let
talking
me.
about?
Um, So we are going to talk about the time bucket function today, and more specifically, uh, let me figure out the layout here. So the time bucket function, which is one of the uh, probably the most popular hyper function um, in the Timescale DB community, uh, and uh, and we are going to look at it from using a stock data set, a stock demo data set, looking at stock prices. It's going to be a very similar uh, process to crypto prices as well. So if you have uh, some setup where you monitor crypto prices or stock prices, or you create like open, high, low, close, volume type of tables and data sets, then this will be relevant. Everything that we will show here. Um, and yeah, so basically that's what we are trying to explore today. How time bucket can be used in those two scenarios, stocks and crypto. So honestly, I only have like this one slide, and it doesn't even load properly. So I guess it's I guess
Awesome.
it's like just a one pager about the time bucket function and some of the things uh, that is useful to know about this function and an example. So first of all, if you have never heard about the time bucket function, it's it basically it's very similar to the standard Postgres function called datetrunc, but it's more useful. It's more flexible in the sense that it allows for arbitrary time intervals. So, for example, uh, in the example below, or the example on this slide is let me get my drawing tool. Do. So here we have 50-minute specified as the time interval, and you cannot do this with date trunk. Uh, so it allows for any minute, any hour, or every week to be set, and this actually makes it really useful if you are analyzing something like stocks data or crypto data, because you have oftentimes you have intraday uh, records like intraday prices, and you have maybe one record per minute per symbol, and it's useful to analyze these prices in 50-minute intervals or 10-minute intervals or 2-hour intervals or whatever you need, and that
Right.
is what time bucket allows you to do.
Yeah. So how's that different from date trunk? Do you remember? Like,
Yeah, so date trunk basically allows you to create. Uh, I think it allows you to create a day, uh, well, sort of buckets, but it doesn't allow you to create, for example, 2-day buckets. I think it
right.
also allows you to do, like, I think it allows week, hour, uh, even month, but you cannot define, like, for example, 15 minutes.
Yeah. It's totally based on your. It's based on the actual timestamp, right? So you're saying get me the day. So all the timestamps within a day, but it's not like you can shift that day around, right? It's as you said at the beginning, it's inflexible, right? It's not like I can just kind of arbitrarily move things.
Yeah. Um, and then with PG14, if you don't know, there has been a new function introduced called datebin, which allows you to set arbitrary time intervals. So datebin works very similarly to time bucket, but it's only available in PG14. So if you use PG13 or 12, you cannot use datebin. Um, and also, one thing that datebin does not support, which is month and year support. So so you cannot set like arbitrary month and years with datebin, and this is actually something
Right.
that uh, TimescaleDB can do, which is the next generation version of the time bucket function. It's currently still in the TimescaleDB experimental schema. Um, so you can try it, you can use it, and you are welcome to provide feedback. But TimescaleDB does allow you to set arbitrary uh, month and year intervals. So, for example, you can set 2-month time buckets or 2-year time buckets. Great. So, as I said, that's the only slide I had. So let me jump over to 𝗔𝗵𝗽 and try some of these things out. Try time bucket, uh, time bucket ng. Also see how you can include time bucket in a continuous aggregate, which people often do, especially when they work with stock data. So let's start. So first of all, a little bit about the demo data set that I'm using. It's going to be a stocks intraday data set. It's an open high low close volume data set. So as you can see here, it has time, symbol, price, open, high, low, close, and trading volume columns. One thing to note here, which we are going to explore further later, is that the time column is a time zone aware column, uh, uh, which uh, which will be interesting later on. And let's see how many rows we have in this table. I run the approximate row count function, and we see that there are more than 9 million rows. Now let's see what is the time range of the data set. So if I run this piece of SQL code, we get that we have data between uh, December last year and November 12 this year. So that is the kind of range we are dealing with, almost a year.
Great.
And so let's run some basic time bucket queries. So first, for example, if you want to see what are the trading volumes, the overall, the total trading volumes on a given day, And as an example, I specified a var close to only include data from October, from 1 month. And so this query uses the time bucket function 1 day as the time interval. And so if we run this, we will get back 1 row for each day. And one thing you might notice is that we have sometimes 2 days where we don't have data, and that is because it's stock prices, and obviously the U.S. Stock market is not open on weekends, so that's why we don't have data for those days. But using a query like this, you can get any kind of aggregated value for the given time interval, in this case 1 day. So that is the basic usage. Here in this next example, I set 15 minutes for the time bucket, and I specify to only see data for Apple, the company, which has that symbol, and for the day of 14 of October. If we run this, we get 15-minute time buckets, and we see the trading volume of Apple in those 15-minute time buckets throughout the day.
Yeah, that's pretty great. It definitely trades in the middle of the day pretty heavily, huh? But not the edges of the day. I guess those would be off market. Yeah, so you
Yeah,
can see when the market opens and closes, I guess, huh?
yeah, probably, because this data set also has records from time periods where the market is actually closed. But
Right.
some
Special people get to trade during that period.
yes, exactly, special people.
Yeah.
So if we want to make things a little bit more complicated, we can create the same kind of open, high, low, close volume table, but only for Apple and for that given day, using 50-minute time buckets. So instead of just getting the total volume, we can use any kind of aggregate functions to get other values as well. So if I run this query, and as you can see, we use some other hyperfunctions and not hyperfunctions in this query as well. Like, for example, the first hyperfunction, which gives you the first opening price in the time bucket, and the last hyperfunction, which gives you the last closing price in the 50-minute time bucket. And so this gives a more detailed view into the 15-minute time buckets. And this could be this is actually one of those queries that people need like continuously, like maybe daily, or multiple times a week or something like that. And to do that, you can use continuous aggregates, which I'm not going to go super deep in this stream, because we have a lot of content around continuous aggregates on our YouTube channel, which explain how continuous aggregates work. But this is an example continuous aggregates definition that uses time bucket. Actually, it uses the same time bucket and the same query that I showed before, and it will create a continuous aggregate for not just for Apple, as we did previously, but for all the other symbols that we are monitoring currently in this database. And I'm also adding the with no data option here to actually not materialize all the data. And then later with the refresh continuous aggregate function, we will only materialize data from the past 2 months to see
Okay.
how it works actually in practice if you create a continuous aggregate like this.
Yeah, from a stock or crypto perspective, this is by far probably the most asked query question, query example, continuous aggregate example we get, Stack Overflow and Slack and elsewhere. So it's a very, very, very typical use case of this kind of time series data.
And using the with no data option also gives you much more control over what actually gets materialized. So if I run this query, we created the continuous aggregate, but nothing is actually materialized yet. And with this next query, we will materialize data from the past 2 months. So let's run this as well. This would probably take a few seconds. And it's already done. And now that we have the continuous aggregate, and we also have materialized data in there, if we want to query the same Apple prices, the same Apple open, high, low, close volume data set, we can use the continuous aggregate now. So let's run this query, but let's comment out the where close to see that actually it's not just Apple what's in there, but other companies as well. We have data about all the other symbols. So if you run this, you can see that we have not just Apple, but all the other companies that we are monitoring.
So
And
Attila, I just wanted to, I don't know, your audio is totally fine, and it might just be me, but your video and your screen has frozen for me, at least within Restream. So I don't know if you
Okay,
maybe quickly try and at least stop sharing your screen and reshare it if something.
yeah. To be honest,
It's hard for me to know.
it's happened to me in the past, but
Ah,
I check it, but it's so Restream has freeze for me in the past, but the actual stream has not. I
oh,
don't
it's
know if
going to. Okay, great. Let's pretend that's the case then. You keep
no.
going. I'll shut up.
Uh,
I'm gonna go look. You keep going.
yeah. Okay.
Oh, there, your screen just came back for me.
Is it or did it?
Yeah, I can. Oh, and you're otherwise unfrozen for me now. Woohoo! All right, go for it. That was
Uh,
fun.
anyway, so I keep going. So if we query, yes, so we see not just Apple, but all the other symbols. And as you notice, this was instant because this is coming from the continuous aggregate. So that's why people like using time bucket function, but also continuous aggregate because it just makes this query so much faster. And if you want to see only Apple, you can have that where close, and then you will see the Apple prices in 15-minute intervals. So the same query that we did before, but this way it's much faster because of the continuous aggregate. Does it look okay now? Like I'm not freezed or anything like that?
Yeah, so I think that we're fine. I'm just quickly watching on YouTube and things look like they're rolling.
Okay, cool. I had a lot of technical issues today, so it wouldn't be a surprise if this doesn't work. Anyway,
It's all good.
uh,
Keep going. I think it's working out.
awesome. So let's look at like the actual value that gets returned by the time bucket function. So first of all, um, by default, the time value that you see uh, in this case, the bucket column, which is the time bucket column, you always see the starting time of that given time bucket. So, for example, here the first value, October 15, 4:30 p.m. So that is the starting time of that 50-minute period. So that's good to know. And also another thing which is actually mentioned in our documentation is that if you have, as I mentioned, we in the table definition. Let me just quickly scroll up. So in the table definition, we created a time zone aware timestamp column, and in this case, what gets returned by the time bucket function is in UTC. So these values are in UTC, but also because currently I'm in UTC1 time zone, I see like the actual values that gets returned to me are UTC plus 1 values.
Okay. Yep.
So
Timestamps are hard.
yeah.
Time zones are hard. Sorry, time zones are hard. Right? There's a few certain things in life, and one of them is that time zones are just tricky.
Yeah, so if I run this query, this one creates an open high low close value data set for Microsoft, Apple, and Facebook between 1st of November and 15th of November. And because the time bucket is creating 1 week buckets, the starting time of the time bucket is midnight. But as I said, I'm in UTC plus 1, so it's going to be 1 in the morning for me. Each time bucket value will be 1 a.m.
Right. Yeah, and that's just so everything. The reason I say time zones are hard, right? I mean, everything is stored in the database in UTC when you have the timestamp aware, the time zone aware column. And so, that's always one of those tricky things where people say, I'm asking for the beginning of the day, and they get something back that. So for me, I'm in UTC. What am I in right now? -5, I guess. So I'm always end up seeing something that's not, midnight specifically, because what's actually being stored in the database is true UTC. Um,
Yeah.
Going back and forth, being all aware.
And then one thing that might be useful if you are collecting stock prices from from the U.S. market is to see these time values, the bucket values in U.S. Time zone, or more specifically in the time zone uh, of the exchange that you are collecting data from. And so, for example, specifically, as I know, the U.S. exchanges, at least on the East Coast, they open at 9:30 a.m. local time, which is UTC -5, and that is UTC 2:30 p.m.
For you.
And so if you want to display the bucket values according to that time zone, you can use the one of the optional arguments, which is origin, which basically helps you make this shift in time. So the default value of origin is, I think, January 1st, 2000, midnight. And so that's the default, but you can change that. And so in this case, I'm changing it to 2:30 p.m. Because that's going to be the opening time of the exchange in UTC time, which we need now because TimeBucket uses the UTC time zone to align the timestamp value.
Right.
So if I run this, the same exact query, only difference is we added the origin parameter argument. So if you run this, we will see that most of these values, most of these time bucket values are starting 2:30 p.m., which is correct according to like my time zone.
Right.
But you can also see values with 3:30 p.m., which are again another time zone thing. Is the clock change?
Yeah.
And
Good
yes,
stuff.
awesome stuff. And so
Oh
because of
yeah.
this, where I am right now in my time zone, we had to change the clock at the end of October, and so that's why you see 2:30 as the time bucket value for November and after that. But before that, you see 3:30 because of the clock change. But yeah, but what this shows is that this is how you can use the origin argument to basically align all the other values that time bucket will create, and this could be useful for in the stock data uh, use case to align the time bucket values uh, really according to the local time where your exchanges where you are getting the data from.
That's great. So Tilla, we have a question from David. I'll just put it on the screen here. It says, is there a speed penalty for longer date time with time zone? David, I assume what you're asking about is when you say longer, and if you want to, if I'm wrong, you feel free to chat in here, is a longer bucket time, right? So if you have 1 week or 1 month or, as opposed to 15 minutes or 5 minutes or what have you. Um, so I'm going to go on that premise and I could be wrong. So please correct me if I'm wrong. I mean, the basic answer is it's an aggregate function. And so if you're aggregating more data, there's going to be it's going to impact the speed or the latency at which the query will return, because it does have to churn through more data. Something like continuous aggregates helps to overcome that. So if you know that you need 15-minute intervals always, that's one of the reasons we created continuous aggregates, so that can be maintained over time, and you can query that aggregate so that you don't take that performance hit every time you query your raw data, and what have you. So if as far as the time zone part of the question, I'm not sure that again, if I'm on the right track, that doesn't specifically impact it much. So using the origin, for instance, it should be the same regardless of whether you have the origin or not. You're just simply giving us a new starting point to do the aggregation from. There's always a date there. The default, I think, as Attila said, currently, is it January 1st of 2001 or 2000? I forget. It's one of them. I actually forget.
It's well, actually the 3rd of
The third.
January
Okay.
2000.
Yeah.
Yeah.
Cool.
And I think I
And
missed.
I think that's also, we had talked about, right? So the origin starts on a Monday. So if you do 1 week buckets, for instance, your starting of the bucket, as Attila said earlier on, the timestamp you see is the start of the bucket, whether it's 5 minutes, 10 minutes, hour, week. And so if you do a week time bucket, it's going to always originate at the midnight on Monday. If for some reason you wanted to shift that to a Sunday, you could give us a different origin for the beginning, like a Sunday, and it should start the week then on a Sunday moving forward.
Yes. Also, one thing, if you have timestamp TZ as the data type, which I think we also mention it in the documentation, is that so that's going to be stored in UTC, like internally,
Right.
and but if you need local time, you can cast your time column or time column to timestamp, and that will convert the value to local time.
Yep, that's a good point. That's a good point. And that's local time to the server
The
that's being
server,
queried. Yeah.
yes, the server.
So if you're in Europe using a
I,
server in Amazon US East 1, unless you set the time zone different. I mean, you can always set that. That's part of Postgres. You can set your time zone for your queries and so forth as a parameter, but it's good to know.
okay, and the next thing I wanted to show is you can also uh, uh, basically offset the value that is actually shown for the time bucket. So, for example, instead of showing the first or the starting time of the bucket, you want to show the middle of the bucket or some other value in the time interval. You can do so uh, uh, using just adding the time interval to the time bucket. So, for example, in this case, instead of so we are using 1 week buckets, which by default would show the first day of the week uh, as the bucket value, uh, which is Monday. But instead of that, in this case, we will show the middle of the week, Wednesday, by adding 2 days to the bucket. Uh, so if we run this without the +2 day, we see 1st of November, which was Monday. But if we add the +2 day, nothing has changed. So the values are still the same, except the bucket value will be
Hmm,
not the start of the week, but the middle of the week.
that's great.
All right. And finally, time bucket ng, which is, as I mentioned, an experimental function at this point. So you can use it using the TimescaleDB experimental schema. And this allows you to use not just minutes, hours, and weeks, but also months and years as your uh, as your argument inside the time bucket ng function. Um, and so, for example, if you want to create 1 month buckets using the time bucket ng function, uh, which you cannot do with time bucket, but you can with time bucket ng. You can do it very easily, and just like that, you can create 3 months buckets as well using the time bucket ng function. and I believe this is actually something that not even 𝗏𝗏𝗃 can do in regular Postgres.
That's correct.
But yeah, TimescaleDB can.
Yeah, again, this
So,
is where I think that the value here, the interesting part of this, both knowing about doing the offset as far as adding days or doing a different origin, is obviously, whenever you provide an interval into time bucket, right, it's always going to start based on whatever that origin date is. So in this case, it's starting. I think maybe it's I'm not 100% sure actually. But with the month, we're saying, hey, we're gonna start at the beginning of the month, and figure out how to make those things. If you do, even a random interval, you do 2 weeks, 3 days, whatever, it's going to start at, you imagine going back to whatever that origin date is, and it's going to create a 2 week, 3 day bucket, and then it's going to create the next 2 day, it's going to figure it out, those beginning timestamps based on that origin. But it's just good to know when you're thinking about, like, why, when I say 1 week, why does it start back on Monday, right? Why doesn't it start right now or whatever that interval is? That's why, and that's where it's starting from.
yeah,
Same
and
thing with
it's
NG.
yeah, and it's I just really like, it's important to be aware of the time zones, like what time zone you are in currently. In some cases, you need to know what time zone the server in that you're using, uh, and then knowing that if your column is time zone aware or not, because if it is, then the time bucket will use UTC, the UTC time zone. So yeah, it
Yeah.
just
So
yeah.
this is the reason I bring that up, is this is an interesting point. I think you had docs up. If you want to, do you have that? You could bring it back. You were showing docs earlier.
Yep.
Because
Uh,
you're showing time bucket NG, this is the one note we have there, which is, so the reason that time bucket uses January 3rd is because we chose that weeks start on a Monday, and that works better for weeks and days and so forth. Time bucket NG, the default origin is actually the first of the month, because the assumption is you're going to work. This is useful for months and longer time periods. So that's why I bring it up. We have some defaults. You can shift things around a little bit, but it's good to know. Good to know that they matter. And you're right, the time zone thing adds into that. It's it all matters.
Great. So if you're watching the recording, there are links in the description for the time bucket documentation, the time bucket NG documentation, and yeah. So I think that's all we
The
planned
only
for.
thing I was gonna,
Yep.
yeah, I was just gonna ask, so you showed all this, particularly for those watching the stream later. Nothing you've shown today relies on, well, I'm sorry, continuous aggregates do. So, that is a specific timescale function. But you go back to your SQL, and really everything else in there is not timescale functionality specific, right? I mean, these are functions we're providing, but you don't need to have a hypertable or a continuous aggregate
Yes.
for most of these things to be valuable, right? Time bucket's actually just a function. If you have a timestamp or a timestamp time zone, if you have timescale installed as an extension, even if it's not a hypertable, you can use this. Approximate row count is just a function we provide. It uses statistics in Postgres. It doesn't have to be a hypertable. You can use approximate row count. I think it's something we don't talk about enough sometimes, that we actually provide a lot of stuff that's very useful. Of course, we think there's a lot of value in hypertables, and the hypertables open up compression, they open up continuous aggregates, they open up data retention. They're the gateway drug of time series data. But there's a lot that we provide that install the extension. Like if you don't use a hypertable, we're not going to interfere with anything else, but you get access to all this stuff, which is pretty cool.
Yeah, and the thing is, like, if someone is already using Postgres, and they have like a lot of data already stored in the table, like as you said, if you just literally install the extension, you can use these functions right
Yeah.
away, uh, and you don't need to migrate your data or anything like that. So that's really really
Yeah.
useful.
We think it will be valuable to eventually migrate, but you'll get a lot of value out of it. You just will. I think it's just a good thing to know. I don't think we talk about it enough. So very cool.
Cool.
Great.
Alrighty. So if you're not part of our Slack community yet, we highly suggest joining. We have, I think, almost 8,000 members, and we have TimescaleDB users and Timescale engineers there. As I said, there will be links in the description about to the documentation, which are relevant to Time Bucket um, and other things that we showed in the stream. And you can also reach us on Twitter if you want to. And I believe that's the last Stocks and Crypto SQL show this year. So happy holidays. And and we're gonna have, I believe, one more Timescale stream tomorrow on Twitch and YouTube.
That's right. Yeah, we still have one more. Awesome.
Awesome. Cool. Thanks, Ryan, for joining.
Yeah, great job, Till. I love it's always fun to see lots of examples of how this stuff works.
All right. Bye, everyone.
Thanks.